This is Jacob's Algebra, Chapter 14, Lesson 4. We're continuing on with irrational numbers. This lesson is about pi. The symbol for pi is, that's a horrible looking one, is this, as best as I can draw, because I'm horrible at drawing. So pi is an irrational number. It has been computed so far out to 10 trillion decimal places, and they have not found anywhere where it repeats or ends yet. 10 trillion decimal places. The two most common approximations for pi are 22/7 and 3.14, but obviously since it goes out to 10 trillion decimal places, there's a whole lot more that comes after the 3.14. Okay, when do you end up using pi? Well, anytime there is a circle involved, you're going to need pi. So the formula for the circumference of a circle is 2 pi r. Circumference is capital letter C. So the circumference of a circle is 2 times pi times the radius of the circle. For the area of the circle, it's pi r squared. And we're going to use the capital A for area. So area is pi times the square of the radius. The other thing we're going to need to remember, first off, r is radius. Important to remember. And then d is going to be diameter. And your diameter is double the radius. So the radius is the distance from the center of a circle to the edge. So let me get a circle. I can't get it to give me a circle. There we go. So like here's our circle. The radius is going to be the distance from the center to the edge. That's going to be our r. The diameter is going to be the distance from one side through the middle all the way to the other side. That is our diameter. Okay. So anytime, this is also an important thing to note, anytime a problem says that your answer needs to be exact, that means that you leave pi in your answer. If it says approximate, that means use either 3.14 or 22/7 in place of pi. So you'll write pi in your answer originally, and then you will replace pi with one of the approximations for pi, and then you'll work the problem and get an actual numerical answer. Okay, so let's start off by doing problem number 4. Problem number 4 says that the ancients used the number 4/3 to the 4th as an approximation of pi. And they want you to write 4/3 to the 4th as the quotient of two integers. So I'm going to write 4/3 raised to the 4th power. To write it as the quotient of two integers, all we have to do is split this up and write 4 to the 4th over 3 to the 4th. Well, 4 to the 4th, we actually know from the previous lesson, because remember we had to make a table of powers. 4 to the 4th is 256, and 3 to the 4th is 81. So that's all that it's looking for part A. For part B, it says change the result to decimal form, correct to 4 decimal places. So at this point, you punch 256 divided by 81 into your calculator, and you'll get an answer that looks like this, 3.1604938. But it says to do it correct to 4 decimal places. So that means we go to our 4th decimal place, which is right here, and that's where we're going to round our answer. So what they want for the answer, I'm sorry, 3.1605. This 4 gets rounded up because a 9 is the number after it. So be careful that you pay attention in the problem to how many decimal places it says to give the answer to. Okay, so let's look now at part C. Part C says, is this value smaller or larger than pi? Well, since we know that pi can be rounded to 3.14, that means 3.1605 is larger than pi. And then part D asks, how is it possible to know that pi is not equal to 4/3 to the 4th without actually doing any dividing? Well, we know that pi is an irrational number. We know that 4/3 to the 4th is a rational number because we can write it as the quotient of two integers. So anything that can be written as the quotient of two integers is a rational number. A rational number cannot be equal to an irrational number. That's how we know that these cannot possibly be equal. Okay, so let's look at a new problem. Problem number 5. Okay, this says the following questions concern the relationship of the circumference of a circle to its radius. Now, the problem that you'll have for homework is comparing the area of a circle to its radius. So it says copy and complete the following table. So for part A, we're going to do a table. So we need to do the radius. And radius has one S, not two. We need to do the radius and the circumference. And I'm just going to write circum because I'm lazy. So we need to do this for a radius of 1, 2, 3, 4, and 5 units. And we need to figure out what the circumference is. Well, remember, the circumference is 2 times pi times r, where r is our radius. So what is 2 times pi times 1? That's 2 pi. 2 times pi times 2, 4 pi. 2 times pi times 3, that's 6 pi. 2 times pi times 4 is 8 pi. 2 times pi times 5, that is 10 pi. Okay, so question B asks, if the circumference of a circle, is the circumference of a circle doubled if the radius is doubled? Well, when we double the radius from 1 to 2, our circumference doubles from 2 pi to 4 pi. When we double from 2 to 4, our circumference doubles from 4 pi to 8 pi. So that's going to mean that yes, it is doubled. Part C asks, how do the circumference and the radius of a circle vary with respect to each other? If whatever you do to x, the exact same thing is done to y, then that means that they vary directly with each other. So how do they vary with respect to each other? That's going to be directly. And we can see that because a direct variation is of the form y equals ax, where a is some constant. In this case, our formula is c equals 2 pi r, and 2 pi is our constant. So that 2 pi is actually our constant of variation, if you remember that from several chapters ago. Okay, so that was problem number 5, and it is just like problem number 12 that I assigned as homework. Okay, let's take a look now at problem number 6. Number 6 says find the exact circumference and area of a circle with various radii. Okay, so you need the exact circumference and the exact area. Since it says exact, that means we will be leaving pi in our answer. So what I'm going to do is make a table. I'm going to write radius on the left, then I'm going to write circumference equals 2 pi r, and then area equals pi r squared. And we'll just do this for a couple of different radii, because radii is the plural of radius. So let's try 0.5 centimeters. So if our radius is 0.5 centimeters, then our circumference is going to be 2 times pi times 0.5, and that's just going to be pi. And we will leave our answer in terms of pi. That means we leave pi in our answer. We don't replace it with 22/7 or with 3.14. Okay, now we're going to look at the area. The area is going to be pi times the radius squared. Well, the square of 0.5 is 0.25, so this is 0.25 pi. Let me make that decimal bigger so you can see it. Okay, let's try another one. Let's look at square root 2. Oh, and I should say that the circumference is in centimeters and the area is in centimeters squared. Kind of ran off the edge there, so I don't have room to write it. Okay, so then what if our radius is square root of 2 centimeters? Well, then our exact circumference is 2 times pi times square root of 2. And that's in centimeters. And there's nothing else we can do with that. Our area is going to be pi times the square root of 2 squared. Now when we square the square root of 2, we get 2. So this is going to be 2 pi, and that's going to be in centimeters squared. Okay, let's look at just one more. What if it's 3 over pi that's supposed to be a pi, centimeters. Okay, then our circumference is 2 times pi times 3 over pi. And our pi's are going to cancel, and we will end up with 6 centimeters. Our area is going to be pi times 3 over pi squared. That is pi times 9 over pi squared. This pi cancels out one of those pi's, so we get 9 over pi centimeters squared. So the problem that you have is just like this. You have to find the exact circumference and area of a circle given various different radii. Make sure that you remember to put centimeters or inches on your circumference and centimeters squared or inches squared on your area, depending on what units you're given. Actually, they're all centimeters. Okay, so that was number 6. It is just like number 13 that I assigned as homework. Okay, let's look now at problem number 7. Problem number 7 says to find the exact radius. So again, exact means we leave pi in our answer, of a circle with a circumference, gives you 2 different values for circumference and 2 different values for area. So let's say that our circumference is 9 pi. If the circumference is 9 pi, we know that that is 2 times pi times r. So we can solve this equation here for r. So what we would do to solve that is I need to get r by itself, so I'm going to divide both sides by 2 pi. And on the left side, my pi's are going to cancel, and what I'm going to end up with is 4.5. 4.5 is going to equal r, and so that's my radius. In this case, there is no pi in our answer because the pi canceled out. Part B, we have a circumference of 14, and we know that equals 2 pi r. Again, to get the r by itself, we need to divide both sides by 2 pi. And so our answer is going to be 14 over 2 pi. We can simplify that. Divide the top and the bottom by 2, and we get 7 over pi. So 7 over pi is our radius. In this case, pi is still in our answer. Let's take a look at the 2 area versions. 7c, we have an area of 9 pi. And so we know that that is pi r squared because that's our area formula. To get the r squared by itself, we need to divide both sides by pi. So we end up with 9 is equal to r squared. And now to get the r by itself, we need to take the square root of both sides. So we get 3 is equal to r. So our radius is 3. Okay, let's look at one more, part D. In this case, our area is 20 pi. So that is equal to pi r squared. And again, to get the r squared by itself, we need to divide both sides by pi. So when we divide the left side by pi, our pi's cancel out, and we end up with 20 is equal to r squared. Now we need to take the square root of both sides, so we'll have just an r. So when we take the square root of both sides, we end up with r equals the square root of 20. Now that can be simplified because 20 is the same as 4 times 5. So we could write this as the square root of 4 times the square root of 5. And we know the square root of 4 is 2. So this is 2 times the square root of 5. So that's going to be our radius. And we're not going to actually calculate what the square root of 5 is because then our answer will no longer be exact. Remember, square root of 5 is an irrational number. So it can't be actually written in decimal form and be exact because its decimal form doesn't end. So anytime you're asked for the exact answer and you end up with a radical, a root of any type, or you end up with pi, you have to leave the pi or the radical in your answer. Don't punch that into your calculator. You can calculate all the rest of it, but you have to leave the radicals and you have to leave pi in your answer because you cannot replace those exactly. So that was problem number 7. It's just like problem number 14 that I assigned as homework, and we'll go over the rest of this in the part 2 video.